So a section on transport of gases, we're pretty much just looking at what is it in the blood and how is it in the blood that we can carry certain gases around. Now, which gases are we talking about? Clearly we're going to be talking about oxygen and carbon dioxide. They're the most central gases that we need in terms of making energy and the waste products of making energy. So looking firstly at oxygen, there are two ways in which oxygen is transported in the blood. I'm sure that many of you will recognise that oxygen is carried by haemoglobin and is called oxyhemoglobin, and that makes it red in colour. And so oxygenated blood has a lot of oxyhemoglobin in. Deoxygenated blood, where hemoglobin maybe goes past muscles, may give off some of its oxygen and may return less oxygenated or deoxygenated, and we sort of translate this as a bluey colour, or a darker red it should be really. So when there's lots of oxygen attached to hemoglobin, it's more red, and then the hemoglobin lets go of the oxygen and it turns a darker colour. Now there's a little bit more detail to that. So red blood cells contain hemoglobin, and so this is what our hemoglobin might look like molecularly. And importantly, hemoglobin has four heme groups, four ion groups here, and that's a larger version of the heme. And it's here that the oxygen actually attaches onto. So each heme group will hold onto a pair of oxygen, O2, 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 O2. So a hemoglobin can carry four pairs of oxygen around. So the two ways to transport oxygen, the majority is carried by the hemoglobin as oxyhemoglobin. 97% of the oxygen is carried as hemoglobin, and 3% just dissolves into the plasma, just stays as part of the plasma and is carried around in the watery fluidy part. But the majority of oxygen is transported as oxyhemoglobin. You need to know the numbers here, so the 3 and 97. Key terms to associate with carrying oxygen or having hemoglobin topped up with oxygen or not is saturated. So at rest, our blood is typically 98% or 98 saturated with oxygen. This millimetres of mercury is a measure for saturation. So blood very saturated with oxygen, this might be a number you would associate it. And if it's just come past the lungs, for example, where gas exchange has happened, the blood will be fully saturated and it will go off to the body where the oxygen will be used. When it comes back from the muscles where it might have been used, the blood is less or unsaturated. And the value you can see here to show how much oxygen is being held onto by the hemoglobin is dropped quite a lot. So venous return or venous blood would be unsaturated, whereas arterial blood would typically be saturated. Looking at carbon dioxide then, it's a common mistake in terms of where carbon dioxide is generated. Now, we use our muscles, we need to make energy to make our muscles work in sport, and carbon dioxide is produced as a waste product of making energy by the muscles. So we actually produce carbon dioxide by our muscles. At rest, we produce less because we're not using our muscles that much. When we exercise, we produce much more because we're making much more energy, so therefore there's more waste product. So be very clear that carbon dioxide is produced by the muscles and is a waste product of making energy. And so here's our CO2, our carbon and 2 oxygen atoms. There are 3 ways in which we transport carbon dioxide in the blood. So you can see it's partly dissolved in plasma, partly it combines with hemoglobin to form carbaminohemoglobin, and the majority of it is transported as carbonic acid. So let's just have a look a little closer at that. So this diagram might look frighteningly complicated, but we'll do it bit by bit. So the first way we transport carbon dioxide is dissolved in the plasma. So here's our 7%. So it's made by our cells during respiration, and 7% of that carbon dioxide just dissolves in the plasma and stays there. That's the first way, 7%. The second way is 23% combines with hemoglobin. So, having been made in the cells, it has to travel into the red blood cell where it combines with hemoglobin. So, CO2 plus hemoglobin forms carbaminohemoglobin, 23%. So that's 7 and 23, 30 in total so far. 7 plasma, 23 carbaminohemoglobin. So finally then, we've got to account for the remaining 70% of the carbon dioxide. And we know that that ultimately gets carried as carbonic acid. So carbon dioxide, this 70% will move into the red blood cell, combine with water, and then leave the red blood cell, but travel in the plasma as carbonic acid. So 70% as carbonic acid, 7 dissolved in the plasma directly, 23 as carbaminohemoglobin, and 70% as carbonic acid in the plasma. So what's the advantage of having an efficient gas transport system? Well, we can prolong aerobic activity. If we can make sure we have lots of oxygen being transported in the blood, then we can get lots of oxygen to our muscles. If we can work aerobically for longer, we can avoid anaerobic respiration, or at least delay it. So that's an advantage in terms of reducing fatigue. If we can reduce fatigue, we can sustain higher work intensities for longer before we are forced to slow down our pace because lactic acid is building up and we start fatiguing. And we can recover quicker. So if we're better at transporting our waste products or transporting oxygen, we can then recover from our exercise much quicker.